Okay, so this is the RC circuits experiment. On the right, what you see drawn on the blackboard is a schematic of a fairly simple circuit. You're going to have a resistor and a capacitor in series with each other and with a battery and a switch. And didn't show it in the diagram, but you're ultimately going to have a voltmeter attached to the capacitor. And when you throw the switch, you will see the voltage on the capacitor rise in real time from 0 to about 1.5 volts, because that's approximately the battery voltage. It'll happen slowly enough that you can actually watch it happen, but quickly enough that it only takes a couple of minutes to fully complete the process. Okay, now there on the left, what you see is an example of the kind of capacitor you're going to use. It's this big can-shaped, cylindrical-shaped thing. Okay, some of them are slightly smaller and different color and so on, but anyway, they basically look like that. All right, so that's the big capacitor that we will use. Now, this experiment is divided into two big parts, two basic parts. The first part of it is more qualitative. We're not going to worry about numbers all that much in the first part of it. It'll be more in the spirit of observing what happens and writing some things down. There's a lot of questions with some word answers to them, and so you kind of get an idea of how this thing works. All right. In that part of the experiment, you're going to connect the ammeter, the micro ammeter, which you see there on the left, into the circuit, and watch what happens when current-wise when the capacitor is charging. Okay. Now, one kind of odd thing about this ammeter is you're going to notice that on the ammeter, there's some kind of resistor attached across the terminals, in this case, a couple of little ones tied together. Okay, so what that does is it changes the range of current that can be measured with the ammeter. That means it basically throws it out of the calibration. So the numbers on the meter don't really mean anything. But like I was saying, this is mainly qualitative in this part of the experiment. You don't really care what the current is, but you want to see how it behaves when it increases, decreases, when it's 0, and that kind of thing. And you can see that pretty well with a analog meter. But don't pay much attention to the numbers, though. Just they won't really mean too much in this part of it. Okay, so that's the qualitative part of it. Then we get to the quantitative part of it. All right, and it's going to be the same basic circuit with just a little bit of a change. You're going to take the analog ammeter out and you'll read resistor voltage instead, okay, in order to get the current. And when you look on that big data sheet in the experiment on page 249, it looks like a real boatload of numbers there. All right, it is a real boatload of numbers. What you're going to be doing in that part of the experiment is you're going to set the capacitor voltage to 0 and throw the switch and write down the voltage on the capacitor and the resistor every 5 seconds while it's changing. Okay, so let me repeat that. You're going to write down the voltage every 5 seconds while it's in the process of changing. Okay, so that's a pretty hectic thing to do. Now, you don't have to do it for very long. It only lasts a few minutes. And then you're going to turn around, and when it gets charged up, you'll discharge it and do the same thing. Write the voltage down every 5 seconds. So you're going to have a whole lot of data on this one. You're going to do a lot of writing down. Okay, and obviously it would be very difficult for one person to do this alone. You pretty much have to have a partner, so one person can write down resistor voltage while it's changing. The other person can write down capacitor voltage while it's changing. Okay, and then once you get all that data, what you'll do with it is you'll enter it into a spreadsheet and create some graphs of the resistor and capacitor voltages and so on, and do some data manipulation on that. There's a process that wants you to go through to find out the energy dissipated in the resistor. The lab manual will explain more of that. Okay, so this will be one time when graphs will certainly be allowed with a spreadsheet. Okay, in fact, I would really encourage it this time. So, okay, you'll have to enter all these numbers in the spreadsheet. All right, let's see. Okay. Now, a couple things that we want to warn you about on this one. One thing that unfortunately happens is when you start any of these processes, you want the capacitor voltage to be 0 most of the time initially, all right? And what you're going to find is if you connect a digital meter to the capacitor, the meter itself actually does tend to charge it up slowly because the battery in the meter itself creates a circuit that actually does charge up the capacitor somewhat. Ideally, that's something we don't really want to happen, but unfortunately it does. But there's a way around that. Anytime you need the capacitor voltage to be 0, here's what you can do. You can just take a wire and, okay, like this, and you can just, don't know how well you'll be able to see this, just actually connect it across the terminals of the capacitor, okay? So just take a single wire and attach it to the terminals of the capacitor temporarily. You can just touch it just for a moment, and that will discharge the capacitor pretty quickly, all right? So you can do that. You will probably have to do that a couple of times. Okay. Now, having said that, I need to put a little disclaimer on it. All right. There's a safety factor involved there, and it's safe in this case for us to do this because I know that the capacitors have not had any large voltage placed on them. Okay. Nobody has taken them out of the room and done that. They stay in this room, and nobody's ever put more than 1.5 volts across it. So it couldn't possibly be charged enough that it would hurt you or shock you or anything like that. Okay. However, generally it's not a good idea to short a capacitor that way. Okay. So like if you were, say, messing around with some old TV set that had tubes, or, well, it wouldn't have to be that old as long as it had a picture tube, or an old computer monitor or something. It could have capacitors in it that might be charged up thousands of volts even when the thing's been turned off for a while. So you wouldn't want to go poking around with something like that. So basically, bottom line is it's okay in this lab for us to short out these capacitors to get 0 voltage. But generally, that's not a good practice. If you find a capacitor just lying around in the middle of the road somewhere randomly, you don't want to touch it. All right, so just so you know that. Okay, let's see. And then, okay, well, on to the report that we're going to do. Okay, well, I've got the requirements on the board. It's actually going to be due in 2 weeks from today, not next week, but 2 weeks, because there is no lab next week. All right, there's no lab next week. So the report is due in 2 weeks. It's going to take some work. It's going to take a couple hours at least. So you'll want to budget some time for that. It's going to take a little bit of time. It's somewhat intensive. Okay, and in the second half of the semester, we won't do quite as much of these hard reports like we have done in the first semester. It'll get easier in the second semester as far as take-home reports go. But anyway, this one is going to be pretty substantial, so you'll want to invest some time in it. Okay. All right. Other big deal is the next time we meet 2 weeks from today, it's going to be the lab midterm exam. All right. So I should talk about that a little bit. So those of you who had Physics 210 last spring semester, we did a physics midterm. We did a midterm exam right before everything got canceled and closed for the coronavirus. So it'll be like that. You come in and you do some work from previous experiments, very much like previous experiments. Okay, it could be anything we've done all semester, but it's basically going to be circuit connecting skills. Okay, so you'll probably, it could be anything the whole semester, but I would say if you look at Kirchhoff's rules, that's probably the most important one. If you can do everything in Kirchhoff's rules, you'll probably be in pretty good shape. but it could be anything we've done all semester. Okay. And other things about the midterm exam. You don't really need to memorize a lot of stuff. There will be a copy of whatever experiments that you need that the exam covers. You don't really know what it's going to be till you get here, but there will be copies of the experiment from the lab manual. All right, so you don't really need to memorize stuff. You need to understand it, but you don't really need to have a lot of formulas and things memorized. Okay. We generally only spend 1 hour on the midterm exam. We may have some other short activity in addition to that too. That hasn't really been decided yet, but definitely the midterm exam, 1 hour, at least that much, 2 weeks from today. Okay,